There's a star in the night sky that's already dead. We just don't know it yet. 650 light-years away, a red giant 900 times wider than our Sun is in its final act. A cosmic titan so massive that if you placed it where our Sun sits, its surface would swallow Mercury, Venus, Earth, and Mars whole. And right now, at this very moment, it could be tearing itself apart. When it dies, and it will die, the explosion will be visible in broad daylight. A second sun will burn in our sky for weeks, perhaps months. Ancient civilizations would have built religions around it. We'll simply watch, helpless and mesmerized, as one of the most violent events in the universe unfolds before our eyes. This is Betelgeuse, and its story is far stranger than anyone imagined. Look up on a winter night. Find Orion, the hunter. There, marking his left shoulder, burns a reddish star that flickers like a distant flame. That's Betelgeuse, and calling it a star feels inadequate. This is a red supergiant, a stellar leviathan in the final chapter of its life. While our Sun fuses hydrogen in its core with surgical precision, Betelgeuse is burning through its nuclear fuel like a cosmic wildfire, fusing increasingly heavy elements in a desperate bid to stay alive. The numbers are almost incomprehensible. 900 solar radii. If Betelgeuse replaced our Sun tomorrow, its outer atmosphere would extend past the asteroid belt. You could fit more than 1 billion suns inside its volume. And yet, despite this monstrous size, its density is so low that it's practically a vacuum, thinner than the air on a mountaintop, just barely held together by its own gravity. Its surface isn't smooth. Imagine convection cells, bubbles of superheated gas rising and falling, each one 100 million kilometers across. Entire solar systems could fit inside a single bubble. This isn't a star. This is a churning, seething cauldron of plasma, barely held together, fighting against the inevitable collapse. And the clock is ticking. When Betelgeuse finally dies, the explosion will be spectacular. A core collapse supernova, releasing more energy in seconds than our Sun will produce in its entire 10 billion year lifetime. But here's the question that keeps astronomers up at night. Are we safe? A supernova doesn't just shine brightly. It unleashes a tsunami of radiation, gamma rays, X-rays, ultraviolet light, powerful enough to strip away a planet's ozone layer from 50 light-years away. Without that protective shield, life on Earth would be exposed to lethal solar radiation. Mass extinctions have been linked to nearby supernovae in our planet's distant past. Scientists call it the kill zone, 25 to 50 light-years. Within that radius, you don't want to be anywhere near a dying star. Betelgeuse sits at 650 light-years away. We're safe, comfortably, undeniably safe. When it explodes, it will be magnificent. As bright as a full moon, visible during the day, casting shadows at night. It will dominate our sky for months, perhaps longer, but it won't hurt us. We'll have front-row seats to one of the universe's most powerful events, and we won't feel a thing. The real question isn't whether we'll survive. It's when it will happen. In late 2019, something strange happened. Betelgeuse began to dim. Not subtly, not gradually. The star lost more than 60% of its brightness over a matter of weeks. Astronomers worldwide turned their instruments toward Orion. The internet exploded with speculation. Was this it? Was Betelgeuse about to explode? For a brief, electric moment, humanity held its breath. But then, just as mysteriously, Betelgeuse began to brighten again. By mid-2020, it had returned to normal. The supernova hadn't happened. So what had? The answer came from careful analysis of the light. Betelgeuse hadn't dimmed because it was dying. At least, not yet. Instead, the star had violently ejected a massive cloud of gas and dust, creating a temporary veil between us and its surface. We weren't watching the star fade. We were watching it hide. This phenomenon revealed something crucial. Betelgeuse isn't stable. It's shedding mass, throwing off enormous chunks of itself into space. This is what dying stars do. They don't go quietly. They thrash. They convulse. They bleed material into the void until there's nothing left to hold them together. The Great Dimming wasn't a death rattle. It was a warning. A reminder that this star is on borrowed time, and every day could be its last. But here's where the story takes a turn. For years, astronomers have tracked Betelgeuse's brightness, watching it pulse and flicker with various rhythms. One pattern stood out: a 2,170-day cycle, roughly 6 years, that couldn't be explained by the star's internal physics alone. Then came the hypothesis: what if Betelgeuse isn't alone? New analysis suggests that Betelgeuse has a companion, a smaller star, roughly the mass of our Sun, orbiting at a distance similar to Saturn's orbit around our Sun. The scientific community has nicknamed it Betelbuddy, though its formal designation is Sawarha. If this companion exists, and the evidence is compelling, it changes everything. Binary systems are common in the universe, but they complicate predictions. The gravitational dance between two stars can affect their evolution, their stability, their lifespans. If the 2,070-day cycle is caused by this orbital companion rather than internal stellar processes, it means Betelgeuse's internal clock might be running slower than we thought. Much slower. Instead of exploding within the next 100,000 years, or even tomorrow, Betelgeuse might have another 100,000 years to go. The imminent supernova we've been waiting for, it might be a cosmic blink away, or it might be a problem for civilizations so far in the future that humanity as we know it will be unrecognizable. The companion hasn't been directly observed yet. But the math is there. The patterns are there. And if Betelbuddy is real, it's been hiding in plain sight, orchestrating the death throes of one of the most famous stars in the sky. And then there's the rotation problem. When astronomers pointed the ALMA telescope array at Betelgeuse, they detected something bizarre. The star appeared to be spinning at 5 kilometers per second. That might not sound fast, but for a star of Betelgeuse's size, it's physically absurd. At that rotational speed, the star should be tearing itself apart. But it isn't. So what's going on? Two theories emerged. The first, stellar cannibalism. Perhaps millions of years ago, Betelgeuse devoured a companion star, absorbing its momentum and gaining a violent spin in the process. It's a dramatic explanation, and it's possible. But the second theory is far more elegant. Imagine a pot of boiling water. The bubbles don't just rise, they create currents, eddies, chaotic motion. Now, scale that up to a star with convection cells 100 million kilometers across. These massive bubbles of plasma rise and fall, creating enormous Doppler shifts as they move toward and away from us. From Earth, this looks like rotation. But it's not. It's chaos. It's the death throes of a star so large and so unstable that its surface is in constant, violent motion. This is the boiling pot theory, and it's the leading explanation. Betelgeuse isn't spinning impossibly fast, it's convulsing. Every observation we make is a snapshot of a star in turmoil, a giant on the edge of collapse, held together by forces we're only beginning to understand. So here we are, staring up at a dying star. Betelgeuse will explode. Maybe tomorrow. Maybe in 100,000 years. When it does, it will be the astronomical event of a millennium, a cosmic spectacle that will rewrite textbooks, inspire generations, and remind us just how small we are in the face of the universe's raw power. But, until then, it sits in Orion's shoulder, flickering, pulsing, hiding its secrets, a companion in the shadows, a surface boiling with 100 million-kilometer storms, a clock ticking down to zero. And the strangest part, it might have already happened. The light we see tonight left Betelgeuse 650 years ago. For all we know, the star is already gone, and the shock wave of its death is racing toward us at the speed of light. One night, without warning, a new sun will ignite in the sky, and we'll finally know